Okay, so there is a special circumstance under which we already know how to solve an exponential equation with exponentials on both sides. And that is when we can rewrite both sides in terms of the same base. If we can't rewrite both sides in terms of the same base, or if we just don't want to be fussed with doing so, we can always just take the log in our favorite base of both sides and then use the properties of logarithms. Unless we have a reason to do otherwise, we're typically going to choose the common log. 1, because then we don't have to write a base, and 2, because then we can throw it into a calculator later. So we have this equation, one exponential expression equals another exponential expression. And our first move is going to be to take the common log on both sides. Okay, why does that help us? The log of a power rule says that we can now pull those exponents out of the logs. So on the left we'll have x plus 5 times the log of 3. On the right we'll have 2x minus 1 times the log of 7. Now, the important thing to remember is that the log of 3 and the log of 7 are just numbers. Right? They're some horrible, unpleasant decimal. They're irrational numbers. But they're just numbers. And we can treat them like just numbers in solving this. So, remembering that those are just numbers, we'll distribute. We'll collect all the x terms on the left and all of the terms without variables on the right. So we're subtracting 2x log 7 from both sides, and we're subtracting 5 log 3 from both sides. Okay, now this next move, if we had nice numbers, it would look like combining like terms. Since we have kind of unpleasant numbers, what it looks like is factoring out an x. So we'll have x times, so what's left of this term is a log 3, and what's left of this term is a minus 2 log 7. And the right-hand side, there's nothing to do at this step. And then this whole expression is just some number. It's a real unpleasant number, but it's just a number. And so we're going to divide both sides by that. We have x equals left-hand side, negative log 7 minus 5 log 3, divided by this expression on the left, log 3 minus 2 log 7. If we want to leave an exact answer, this is what we say. Or if we want to give a decimal approximation, we get that x is about negative log 7 minus 5 log 3 over log 3 minus 2 log 7, about 2.66. And we can check that. 3 to the 2.66 plus 5, that's about 45/16. 7 to the 2 times 2.66 minus 1. That's about 44/75. So you might be wondering, are those equal? And the answer is yeah, I rounded my x. Those are about as close to equal as we can expect with this much rounding. You'll notice that when we round our values, our exponentials can actually end up being a long way off. That's why we like giving those exact solutions. But this much difference is okay when we're taking powers of big numbers. This is just what happens. Okay, things to note. This equation had one exponential expression equals another exponential expression. And that's about the best we can do. We can't really handle it if we have anything much more complicated than that. For one thing, because exponential expressions are always positive, it's very, very easy to get an equation with no solution. So here's an equation where I'm adding together two exponential expressions, and I want to get 0. But we know that this exponential expression is always positive, and this exponential expression is always positive. So when I add them together, if I add together two positive numbers, I certainly get a positive number, no matter what. But that expression then, right, that's the left-hand side of this equation, is always greater than 0. So it can never equal 0. And the equation has no solution. That's it. In general, if there's addition in our equation, we're stuck, right? Here's an equation with two exponentials equal to each other. We might try that move where we take the log of both sides, but now we're stuck. Why are we stuck? Because in general, we can't split up the log of a sum. For an equation like this, we'll generally resort to numerical techniques. There are certainly numerical techniques that can get us a solution to this equation quite easily, and you'll learn many of those in calculus. But at this point, we're going to recognize that that equation is one that we just don't have the tools available to solve. In general, unless we're lucky, if we have more than two terms in an exponential equation, or if the signs are weird, we just can't solve it. Either we can know that it has no solution, or we can suspect that it has a solution, but we can't find out what it is.